Hello and welcome to class. This is radicals and rational exponents, and we're going to start with a warm-up like we normally would. And so I want you to go ahead and try to simplify each of these expressions to the best of your ability. So I want you to pause this for a couple of minutes, work through them, talk to your neighbors about them, and then in a minute you can start it again and I'll go over them. Okay, so hopefully you had the opportunity to kind of discuss them. On number 1, we'll look at that one first. First of all, your answer that hopefully you got was 4 square roots of 6. Okay, so basically what you wanted to do was, just like we did in the warm-ups in class last time, you want to reduce these. You want to simplify these radicals. So if you're looking at 8, that simplifies into 4, which is a perfect square, times 2. And then 12 also simplifies into 4, which is a perfect square. And then that would be times 3. So if I come over here, I can write now, I'm going to take out that 4, that becomes a 2. This 2 stays in the square root. And then I'm going to take out this 4, that becomes a 2. And this 3, of course, stays in the square root. So now we can simplify that some more. We can multiply these two numbers and get 4. And then you can actually multiply the square roots. You can't add square roots, but you can multiply square roots, and you get square root of 6. So that's how I got that answer. So if you were stuck and you didn't know what to do, now you kind of maybe have a starting point. So try number 2. Go ahead and pause if you need to, and then come back and I'll explain it to you. Okay, so for number 2, same idea. I want to break these down. Okay, so 12 breaks down into 4 and 3. 4 is your perfect square. Unfortunately, 15 doesn't break down into anything perfect. So what do we do? Well, let's go ahead and just sort of try to break these down and play with them a little bit. So over here, the square root of 12, I can break down into 2 square roots of 3. And then this square root of 15, I could theoretically break it down into square root of 5 times square root of 3. That's allowed, no problem with that. But you notice now that I have 2 of these that are square roots of 3. So if you wanted, you could actually factor out a square root of 3. Over here we have a 2 left. Here we have a square root of 5 left. And so that's an answer you could write. Whether or not it's more simplified than what we started with is debatable, but it's certainly possible. Okay, so if you haven't already done number 3, try number 3. I'm going to give you a hint. Instead of taking the square root, you're taking the cube root. And so you're looking for perfect cubes. So what times itself would equal the things inside. So take a minute and look at that. Okay, so for number 3, we're taking the the cube root of 8x to the 6th y to the 4th. So let's break these down a little bit. If we look at 8, we can actually split it into 2 times 2 times 2. So 2 times 4, or 2 times 2 is 4, and then 4 times 2 gives you that 8. So you see that 8 is already a perfect cube. So in order to simplify that, we can just take the 2 out. So the cube root of 8 is 2. And we have left the cube root of x to the 6th, y to the 4th. And I'm going to rewrite that, and hopefully you kind of see something that you can do. We have the cube root of x cubed times x cubed. That makes your x to the 6th. And y cubed times y. So this is a lot like one of the problems that we did last class period where we split up the y's like that. So now you see that we can take out x cubed. So we have 2x cubed. So when you take the cube root of them, I'm sorry, that's wrong. It wouldn't be x cubed, it would be x. So the cube root of x cubed is x, and the cube root of this x cubed is x. Okay? And then the cube root of this y cubed is y. And so what's left in the cube root is just this lonely little y right here. And so now we could simplify and say 2x squared y cube root of y. So that could be the answer that you have there. Okay? So now the last one, if you don't already have it, I want you to think about the difference of squares. And I don't want you to multiply it out because that would be a waste of time. So think about difference of squares. Pause it if you need to, and then I'll explain it. So for number 4, it's the difference of squares. And so essentially, you're looking at 5 squared minus square root of c squared. So remember, when you have two things that are squared and you're subtracting them, you put the square root of each of them there, and then you put one plus sign, one minus sign. So if you simplify this, you have 25 minus c. So the square root of c squared is just c. So that would be your answer for number 4. Okay? So we're done with our warm-ups. Here's your objective for today. Pause the video here, and you need to write it in there just like we normally write it in there. Okay? So we are talking about rational and irrational exponents, and really only thing we're going to work with very much is the rational exponents. And if you remember, rational numbers are numbers that can be written as fractions. So it's some integer over another integer. Okay? Irrational are the ones that cannot be written as fractions. So that's the first thing that we'll sort of talk about, and then we'll simplify some expressions that have radicals. So it's, or not radicals, but more so the rational expressions. It's kind of like what we did in the warm-ups, but we'll be using fractions instead of square root symbols. Okay? Okay, so the first question, I kind of addressed this already, is what are rational exponents? And I said it was like if you had a fraction with an integer that's an a over b. Here's the actual, oh, I thought I had it on there. So rational exponents are exponents that are written as fractions. So you can go ahead and put that as part of your notes. And the next question is, what are they useful for? Well, the thing is that square root signs, radicals, are sort of outdated. Once you get into higher and higher level math, these are entirely useless. And so we use them to replace square roots, or roots in general. We call them radicals. So as you get into calculus and such, you will see these, but you're expected to change them immediately into rational exponents and not ever worry about them, okay? Okay, so if you look at the paper that I gave you, the same paper where your warm-ups were, we're going to talk about how to convert things into rational exponents. So I'm going to show you a couple, and then I want you to try to do the rest on your own. So this first one, anytime you see a square root, it's going to be x to the 1/2, and then that's it. So you can just memorize square root is x to the 1/2. So if you look at, for example, well, let's make believe hypothetically. Number 6, let's say that were the cube root. Okay, so it'd be x to the 5th, and then cube root, just like square root, would be 1 over 3, but you could simplify that and say that it's 5 over 3. So the rule that you want to learn is whatever's on the inside goes on top, whatever's on the outside goes on bottom. Okay, so pause the video here, and I want you to do 7, 8, 9, and 10, and then I'll go over them. So go ahead and pause it. Okay, so for number 7, we have x, and then it would be 24 over 4, y to the 3/4, and z to the 7/4. So on all three of them, I put these numbers in the numerator, and then this number went in the denominator. And you may notice that 24 over 4 could be reduced. It could be x to the 6th, and then y to the 3/4, z to the 7/4. Okay? On number 8, this one's kind of tricky. I'm going to write it down here where I have a little bit more space. We have x4 is in the numerator, 1/2 is in the denominator, and then y, and again 6 is in the numerator and 1/2 is in the denominator. So remember when we were dividing fractions, 4 over 1 divided by 1/2, which is this first one, is the same thing as saying 4 over 1 times 2 over 1. So this would end up being x to the 8th, and by the same reasoning, it would be y to the 12th. So that would be your answer there. Okay. On numbers 9 and 10, I didn't really go over this a minute ago, but hopefully you already know this. When you have a negative exponent, or when you have an exponent in the denominator, those kind of work together. So this first one could be rewritten as x to the -2. So by using a -2 exponent, I took it out of the denominator. So pause for a second and try number 10 on your own. Okay, so number 10 is pretty sneaky because I put a negative exponent in the denominator. So I'm going to rewrite this, and I'm going to say x cubed, and then this would be y squared. So this guy could go on top and become positive, and then it's over, maybe that's an x I wrote on it, I shouldn't have written on it. Yeah. So then it's over x to the 7th, but it says eliminate any fractions. So we're going to now write this as x cubed y squared x to the negative 7th. And then you can even take it a step further and say that these two x's kind of combine. So you end up with x to the negative 4th y squared, and that would be your answer. Okay? Okay, so the next topic that we're going to discuss is simplifying expressions with rational exponents. So once you mastered the idea of changing the rational or the radical into an exponent, you need to be able to simplify things. So I'm going to do number 11, and then you guys are going to try the other 3 on your own. So on this one, I'm going to do it down here. So we're going to distribute this 2/3. Remember, we can distribute as long as there's not like a plus sign anywhere in between here. Because these are all being multiplied, we're allowed to distribute that 2/3. So we have 8 to the 2/3, r to the 3/4 times 2/3, s to the negative 3 times 2/3. So we can simplify this, and anytime you get a number with an exponent, in general, we're going to expect you to simplify them. So the trick is to take care of the denominator first. So that's essentially 8 squared to the 1/3. So I separated that fraction. Actually, let me write that differently. Let me say 8 to the 1/3 squared. So it doesn't matter how you rewrite this as long as 3 is always in the denominator. So this is the way that you want to go, and you're going to have some problems like this on your homework that are kind of tricky. You want to worry about the fraction, the denominator first, and then worry about the numerator second. So 8 to the 1/3, it's asking for the cube root of 8. Well, we talked earlier about how the cube root of 8 is 2. So I'm going to replace 8 to the 1/3 with 2, and then this is squared. So 2 squared equals 4. So this guy right here, 8 to the 2/3 power, is just 4. So if we finish simplifying this, we have 4r, and then here you see that we have, I'm going to write it here, 3/4 times 2/3, that's this right there. The 3's cancel, the 2 and the 4 kind of cancel, so you end up with r to the 1/2. Okay, and then same thing here, we have negative 3 over 1 times 2 over 3. These 3's cancel, and so you end up with s to the negative 2. And so that would be your answer there. Okay, so I want you to now do 12, 13, and 14. Just use your rules of exponents. It's just a little harder because they're fractions. So I finish that, and then we'll go through it. Okay, so on number 12, we can distribute that x to the 1/2. So we have x to the 1/2 times x to the 3/4 minus x to the 1/2 times x to the 3/2. And if you remember with the way the exponents work, if these bases are the same, you add these two exponents. So we have x to the 1/2 plus 3/4 minus x to the 1/2 plus 3/2. Okay, so 1/2 plus 3/2, we have x to the 2/4 plus 3/4, so we have common denominators. Same thing here, I want common denominators, they already have that, it's 2. So now we can finish simplifying. 2/4 and 3/4 makes 5/4. And then here, 1/2 and 3/2 makes 4/2, which simplifies to 2. So that could be your answer that you would write there. Okay, on number 13, same sort of idea. We have x to the 5/2, y to the 4th, x, and I'm going to go ahead and distribute that negative 2. Remember, you're allowed to distribute negatives as long as these are all being multiplied. So we have x to the negative 2, and then y to the negative 14 over 4. Okay, so we're going to combine things together. These two x's can go together, and we end up with 5/2 minus 2. And then these two y's can go together. So we end up with y to the 4th. Oops. Yeah, we're going to erase this. So we have y to the 4th minus 14 over 4. And so if we were to get common denominators, we have here 5/2 minus 10/2, y to the 16/4 minus 14/4. And so this ends up being x to the negative 5/2 y to the 2/4, which is 1/2. Okay. So now, let me erase my slide. So now for the last one on this page, remember we don't like radicals. They don't look right. So we always convert them into the rational exponents. So this first guy would be c to the 5k to the 1/10. And then the second guy would be c to the negative k to the 1/2. And then all of that, because of this square root, all of that is to the 1/2. So we can simplify this a little. This first guy, we can say c to the 5k over 10. And then this guy, we can actually multiply these two and this one too if we wanted. So we would have c to the negative k over 4. Okay, so this first guy simplifies, of course, to k over 2. And we have c to the negative k over 4. We could then say that c to the k over 2 minus k over 4 would be our answer. We can simplify that. Oops. Oh yeah, that's what I want. Oops. Hold on. Okay, so we have 2k over 4 minus k over 4. So I multiplied this by 2, and then that leaves us with k over 4. So that would be your answer for that one. Okay. Okay, so now we're going to talk about rationalizing the denominator. And I know that this is something that for sure you should have learned in Algebra 2, so I'm hoping that it's familiar to you. But the question is, what is rationalizing? What does that actually mean? And if you remember, that's when you're not allowed to have a square root in the denominator. So if you have like 5 over square root of 2, you have to get rid of that square root. And when you get rid of it, that process is called rationalizing the denominator. So the question is, I'm not sure why I put why not, but I meant to ask, why do you have to learn it? And the reason is that it's convention. So essentially, there's not really any mathematical significance. You have 5 over square root of 2 is the same thing as 5 root 2 over 2. The thing is, though, that you have to be able to recognize that this would be the right answer for this. Otherwise, you're not going to be able to get it right on tests. So that's why we learn it. That's why we teach it, is for the sake of understanding the common nomenclature and the common conventions that we use in math. Okay? And so how do we rationalize the denominator? Or how do we get rid of the square root in the denominator? And that's where we rationalize it. So that whole process, getting rid of the square root, is rationalizing it. Okay, so let's do some examples. If you already remember how to do this, go ahead and pause, and then you can come back and just check your answers. I'm going to do number 16 first as an example. So 2 over 3 plus square root of 6. And so in general, the key is you're going to multiply by the denominator. But in order to get the whole thing to cancel out, you need to change this sign. So since that's a plus, you're going to change to minus. And so when you multiply that out, you get 6 minus 2 root 6 in the numerator. And then in the denominator, you see that it's the difference of squares, which is why we had that example in the warm-ups. So this would be 9 minus 6. So I squared this, squared that. That's the answer there. So if we simplify that, I have 6 minus 2 root 6 over 3, and that would be the answer. Okay, so if you haven't already, go ahead and pause and do 15 and 17, and then I'll go over them. Okay, so for 15, you should have 7 root 5 over 5, and so I just multiplied by square root of 5 on top and bottom. It looks like this. And on number 17, it's a little bit less straightforward, but I have this answer. So I can go over that. Let me write the answer again. And I lost my place. Okay, x minus root xc over x minus c. So we start out with this. And I told you that we want to multiply by the denominator. So we have x root c, or x root x, root x root c, root x root c. And usually you put a minus sign, or rather a plus sign, because that's minus here. Honestly, on this one it wouldn't matter. You could put a negative in front of the root x instead, but only one of them should change sign. So if you decided to put a negative in front of the root x, then you would want to keep the negative in front of the root c. Just change one of the signs. But in general, it's easier to just change it after the or before the second one, just because we're used to doing that. So if we multiply, square root of x times square root of x is just x, and then we have square root of x times square root of c. And in the denominator, we have essentially the difference of squares, because this is plus and this is minus. So we have x minus c. And then I just simplified it. I put those together, and I ended up with my answer. Okay. Okay, so now on this one, we're just going to simplify these, and this is without using the calculator. And it's just like the one that I did in the warm-up, where I said you wanted to take care of the denominator first. So if I rewrite number 18, I'm going to have 81 to the 1/4, and then that negative 1 I'll wait until later. So 81 to the 1/4 would be 4. So if you do 4 times 4 times 4 times 4, you get here 16 times 4. Nope, that's wrong. Sorry. What I meant to say was 81 to the 1/4 is 3, not 4. So if you have 3 times 3 times 3 times 3, this is 9, times 3 is 27, times 3 is 81. So we get 3 to the negative 1, so I just replaced that with a 3. And you could rewrite it as 1/3, you could leave it as 3 to the negative 1. Both of them are acceptable. So pause the video now and do 19 and 20, and then we'll go over them. Okay, so for 19, again, I want to address the denominator first. So I'm going to say 16 to the 1/2, and then that's cubed. So 16 to the 1/2 means the square root of 16, which is 4, and that's cubed. So 4 times 4 times 4, that's 16 times 4 is 64. Okay, and then for the last one, again, take care of the denominator first, and then worry about the numerator. So we have negative 64 to the 1/3, and then that whole thing is going to be squared, and so we're looking for the cube root of negative 64, which is negative 4. So negative 4 times negative 4 is positive 16, times negative 4 is negative 64. So this can be replaced with negative 4, and then that's squared, and negative 4 times negative 4 is positive 16. So hopefully that kind of addressed all of your questions. If you have more questions, you can send me a message. But other than that, if you still have class time, go ahead and start working on your homework. The problems are written on the bottom of your worksheet that you were just doing these on. And you will have a quiz next time. As a hint, the material that's on the quiz comes entirely from that page, whatever page it is, I forget what page number, but that same page that your homework is on has all of the quiz questions on it. So if you work enough of those extra problems out, you should be able to get 100 on your quiz without any problem. Okay?